mobility. A concept that humans have pondered over for centuries, if not millennia. And experts keep coming up with the same questions. How can we transport more people and freight? How do we make mobility as safe as possible? And most of all, how do we make it environmentally friendly? About 8 billion people around the world want to enjoy mobility. About 4 billion people fly on planes each year. And about 1 billion cars drive on our roads. Cities are growing, traffic increasing, and environmental pollution is getting out of control. New environmental movements like Fridays for Future and activists like Greta Thunberg denounce the state of affairs. There is little time to act. Climate change is man-made and almost impossible to stop. At the same time, digitalization radically changes entire industries and society as a whole. And that opens up new opportunities. We meet experts who rethink mobility and who make it possible. They use 3D metal printing and create coatings for components used in cars, airplanes, and space travel. Our film enters the world of hidden high-tech, super technologies intended to make mobility and our cities safer and cleaner. Around the world, companies work on making manufacturing more efficient and environmentally friendly. We are visiting a Swiss company called Oerlikon that develops and makes products for the aerospace and automotive industries. The Italian engineer Alessia Toscano, for example, works with 3D printing.
I think that with AM you can customize your own part. If you have any part that it's in your mind, you can just have the freedom of design to do whatever you want to print. So I think this is the only technology where you can do this, and that will be the key for the future.
She's on a trip to Switzerland, where she wants to talk to her colleagues at Oerlikon on the topic of coding. But first, she takes a break to show us which car parts will soon be printed, rather than made conventionally, including pistons of combustion engines and gas pedals. And what are examples of 3D printed components?
So, for example, for a car, I can say we can produce in AM the bracket, the hinge that makes you close your door in your car. Or, for example, for a plane, we can AM manufacture the blade and the turbine. And then for rockets, we are also working to manufacture more and more parts. So AM now is evaluating all the possibility of all the components in every sector.
So what is additive manufacturing? How does powder turn into a part? And where can we learn more about this technology that is considered an industrial revolution?
Well, of course, we have in Oerlikon AM different plants in USA. For example, we just opened a new center in Huntersville, and they're doing a lot of development.
Alessia continues her trip. We will meet her again later. But first, we are going to America. There, on the southeastern coast near Charlotte, a new factory for 3D metal printing has just opened. Here we are going to meet leading specialists in the field of additive manufacturing, whose previous clients include NASA and Lockheed Martin. They develop and manufacture components for aerospace applications. Right now, they are using a metal powder to print an antenna bracket that is far more rugged and lighter than anything that came before it. This part was developed by RUAG as a demonstration of what could one day fly into space as part of a communication satellite, which provides navigation support using digital geodata.
So Oerlikon AM focuses mainly on additive manufacturing, which is often referred to as 3D printing. We focus mainly on metals here. So you'll see behind me there's actually some of the printers that we have that do the additive manufacturing process. And what we're trying to do here, our goal is to industrialize AM so that we're no longer in the prototype world, we're now moving forward into the production world and making parts that ultimately are going to fly on planes.
This factory is the only one of its kind in the US, featuring all the relevant production steps under one roof. From powder blending and testing to printing, heat treatment, finishing, and quality assurance. You could say that here, components are literally made from dust. We want to understand this better. How does 3D metal printing work? And what makes it so fascinating? Later, we will return to see what became of the antenna bracket. To get more detailed information, we are visiting a scientist who's deeply involved in researching additive manufacturing at one of the oldest universities in the country. Penn State University in Pennsylvania. Here we're meeting Abdallah Nassar. With his students, he continues his quest for new applications of this technology.
So today, additive manufacturing brings together very advanced computer systems that allow you to design very complicated features with the ability to actually build those features using technologies that require lasers moving at very rapid speeds to build up parts literally out of powder. And the newest, where the technology appears to be going is in building ever more complicated structures. Building structures that have never been before built. Building structures that look like nature. Something that doesn't look like it's been manufactured by a human being. And what those allow us to do is optimize design so that we can get the best performance out of every component that we build components for custom applications, whether that be for an aerospace application or for a custom car application or for an implant that you put in your body.
But what differentiates 3D printing from conventional manufacturing methods?
Classically, designers thought in terms of boxes. Everything was a box, and what you do is you had to take away material from that box to build your finished components. Today, we're reversing that paradigm entirely. Rather than starting from a box, we're starting from nothing. And we're adding little blocks or little layers or little tracks of material one at a time to build up components additively. That's why it's called additive manufacturing, rather than conventional subtractive manufacturing.
Here's an example that shows how important 3D printing will be for the future of mobility.
So in this particular case, this structure is to hold a very simple sensor that's put on a aerospace application. But again, without those sensors, your airplane can't fly. So it's a little device that all it serves is to mount some sensors on your vehicle. But without it, nothing happens.
We are returning to the production of the antenna bracket. It's coming along nicely, but needs a little more time for what's going on beneath the surface. In the meantime, we keep exploring the factory. This time, the quality testing lab. Because quality is everything, whether in cars, airplanes, or even orthopedic implants. If the metal powder for 3D components is used properly, the final product will be lighter, stiffer, more efficient, and environmentally friendly.
One of the main aspects of additive manufacturing, with the design freedom, we are able to produce parts which are just needed for the application. So we are reducing the redundant material in the component, so thereby we are serving the actual application, as well as we are reducing the weight, and thereby we are reducing the energy consumption of the component from the manufacturing to the end of its life.
With additive manufacturing, pollution is reduced right from the start, when the material is transported to the factory. There is almost no waste in the process, so less material is needed compared to conventional machining. A laser beam is used to melt the powder into the shape of the final component. and create geometries that might otherwise be impossible to manufacture. 3D printed parts are also important for another mobility application: space flights. In the coming years, humans will go back to space, and additive manufacturing will play an important part.
When it comes to aerospace, two things matter. One is functionality, and second one is the lightweight structures. When you manufacture something out of conventional manufacturing, one is design constraint, and also you do not have enough incentive economically for removing the redundant material. But in space application, like I said, the performance is very important, and also the lightweight structure is important. Both can be realized using additive manufacturing. So these aspects make additive manufacturing is very, very viable technology for aerospace and future space flight missions.
And then the wait is over. The antenna bracket for the satellite is finished. Like an archaeologist, a technician uncovers the bionic part. It looks a bit bizarre, almost like something you would find in nature. In the field of bionics, experts emulate successful structures found in nature. A classic example is the honeycomb, which is very sturdy but light at the same time. Strain on the honeycomb is distributed across the entire structure and thereby prevented from causing local damage. Bionic honeycomb structures use this very principle in everyday applications.
We learn from nature in terms of understanding that particular types of structures are particularly suited for a specific application without having to go through the math. But the interesting thing is that if you do go ahead and go through the math, what you find many times is that the natural structures are the optimized structures. So it's a back and forth process where we're inspired by nature. And then we use that inspiration to go back, do our engineering calculations, and come up with the structures that we really need to fit an application.
Now the production of the antenna bracket goes into its final phase. A technician removes the structure from its base, using an electric wire that is heated to a temperature of several thousand degrees. Then the component needs to be inspected via a blue light scanning process, which is fitting since the bracket is designed to be launched into space on board an ultra-complex and expensive satellite.
So both additive manufacturing and coating technologies absolutely influence your everyday life. They're already impacting the aerospace, the medical industry, and there are more and more gaining traction into everyday consumer items. The car you drive will have many additively manufactured parts. The planes you're on already do or will soon have hundreds of additively manufactured parts. Even within your body, you will soon likely have an additive manufacturing implant when you get old.
Next to additive manufacturing, there is another hidden form of high tech: surface coating. Why is it so important?
Because surfaces come into contact with everything. They come into contact with the outside world. And the outside world is, unfortunately, sometimes a bit too harsh. So you can have your component designed perfectly with a material that will withstand all the forces.
To withstand these harsh outside forces, the coating process has to employ harsh forces as well. We return to Switzerland. Here we meet Alessia again, who is inspecting a completely new machine together with her colleagues. The automated room-sized machine for thermal spraying is the only one of its kind in the world. It can coat components for the automotive and aerospace industries, using temperatures that are even higher than those found on the surface of the sun. What is special about this machine and this technology?
It's pretty compact. It fits into a shipping container, which also leads to a reduced lead time in developing, and installation time is also reduced because it's all frame-based. So we can put it into a shipping container, pull it out, stick in, plug in water, electricity and gases, and then it's installed. So this is a huge step for our industry.
The small factory is fully automatic and uses a robot to perform the work. Simply put, the part inside the machine is bombarded with metal powder and superheated by a flame. The temperature inside the flame can reach up to 16,000 degrees Celsius. The surface of the sun barely reaches 5,500 degrees. Molten particles reach the part and cool off, thereby forming a new ultra-resistant surface layer. Right now, the machine is coating a cylinder used in truck engines. What does this coating do exactly?
Thermal spray has a wide variety of applications for mobility, but to give you a couple of concrete examples, fine dust emissions from automobiles is a major problem, and there are numerous environmental regulations coming out with regards to that. This is a perfect example of a brake disc from a typical car. With our coatings, we reduce corrosion and also the dust emissions from these brake discs, thereby increasing the lifetime of the brake disc, but also helping the manufacturers achieve their environmental goals.
And that's very important because according to Germany's environmental agency, the abrasion of brakes, tires, and roads now accounts for almost 60% of all particulate emissions. The cylinder is now coated and ready to start its life out on the road. Various different coatings are used in the mobility sector. The process employed depends on the final product. Parts inside an airplane's engine have to withstand temperatures exceeding 2,000 degrees Celsius and require a different coating than parts used on the outside or inside of a car. A lot of progress is being made in this field right now. For example, the so-called EPD process, used by Oerlikon Balzers, applies super thin coatings with special properties. To learn more about this hidden technology, we are going to the country that is home to the largest automotive market in the world, China. In Suzhou, 100 kilometers west of Shanghai, there is a machine that will play a big part in shaping the future of cars. Here we are meeting Louis Zhang, an engineer who studied in Germany, among other places, and who is an expert in coating technology, particularly the new EPD process. The process happens in a so-called clean air room and does not require any substances that would be harmful to the environment. EPD is a replacement for the galvanizing process. This form of surface finishing is problematic since it uses substances like chrome-6. It also uses large amounts of water, pollutes it, and endangers people who come in contact with it. That's not the case with the EPD process. The giant, fully automated machine applies metal coatings to plastic parts, like trim parts for cars, in a way that is completely environmentally friendly. Today, the machine is processing hood ornaments for Chevrolet and Buick, so the efficiency and environmental friendliness of mobility begins with coatings used on small plastic parts in our cars.
All right, so now we can see here two cars beside me. And in my hand, I have the product you saw that before in the factory. This has been coated in EPD before.
Look at you around in your car. How many plastic parts around your cars? If you add everything together, getting 30% weight reduction, which means for a reduction of emissions like CO2, like other poison gases. And the lighter weight of the car, the less emission, the less consumption.
The Fraunhofer Institute for Additive Production Technology estimates that 3D printing can save 6 tons of CO2 emissions per kilogram. Whether it's 3D metal printing, new materials, or the latest coating technology, components keep getting lighter. And less weight always means less harmful CO2. Increasingly smoother and harder surfaces, less wear and tear, lower weights and lower fuel consumption. That's the formula of the future in the field of coating. But the EPD process has an additional function. Cars that drive autonomously will have a large number of sensors on board, including those mounted behind the brand logo on the radiator grille. In future, these logo badges have to allow laser and radar beams to pass through, so the relevant sensors can do their job. Only in this way will technologies like 5G become usable, and in turn make autonomous driving possible. So surfaces and materials are a decisive factor for the cars of the future. But why are materials so important?
Materials dictate literally life and death for us. Today, ever-advancing materials are required to fly your airplanes. You cannot fly an airplane without aluminum and titanium, materials that are just fairly recent when it comes to world history. Where we're at today is being able to digitally design everything. We're in the digital age.
Let's go back to China. Digital and green technologies are taken very seriously here, as can be seen in the area surrounding the city of Yangzhou. Traditionally, Yangzhou has had a large concentration of chemical companies, and that had an effect on the air in the region. But things are changing. Big car companies like Volkswagen have settled here. Their goal? Using clean manufacturing to offer clean products. Just a few final touches before the big launch. In Yizheng, Chinese automotive supplier Dafang Wuyu is preparing its new EPD coating machine. In a few days, it'll go into continuous operation for large brands like Volkswagen and General Motors. The general manager explains why coating technology is so important. That's to do with the broad spectrum of applications of coating and EPD technologies, from the engine all the way to the body. As car making moves toward lightweight construction, smart design, autonomous driving, 5G, the Internet of Things, and the networking of vehicles, this field of applications will continue to grow in the future. The EPD technology is a dry coating process. Because of it, coating processes have improved significantly. Since traditional chemical processes cause significantly more pollution of the air as well as subterranean water. The fact that environmental protection is now taken very seriously in China is reiterated by a government representative who appears on the day we're filming. Promoting innovation, structural change, the continuing development of production processes, and environmentally friendly production are goals that the Chinese government has been pursuing for a long time. Therefore, new processes and technologies used by high-tech companies such as DFWY are permitted in order to give even more impetus to the industrial sector. But is that enough? Can hidden technologies really improve our carbon footprint in the future? After all, there are now 8 billion people on planet Earth. By 2100, this number is expected to climb to 11 billion. The urban sprawl continues. In addition, the demand for cars is increasing, particularly in emerging nations. Let's take a megacity like Shanghai, for example. With a population of now 26 million people, mobility has to remain clean. Perhaps the World Environment Day, which takes place on the 5th of June each year, can help.
So on this Environment Day that we have today, it's a really good celebration of additive manufacturing technology as well, because it's one of the tools that will hopefully reduce our carbon footprint and our overall impact on the environment. It will help us optimize energy savings for everybody.
Additive manufacturing, or industrial 3D printing, and surface technologies will play a role in how safe and clean our mobility will be. Despite trade wars, experts like Alessia Toscano and companies like Oerlikon are already working on it. on a global scale and across borders.